Good afternoon everyone and welcome to Hutsons-Hacks. I'm going to start to do a new set of tutorials taking you through some tips and tricks in R and Python. Today we're going to be looking at deploying a CARET machine learning model as an API with Plumber. This will show you how to build the machine learning model and then create a Swagger file using Plumber on the back of that. And then I'll put some links into the deployment options and perhaps do a follow-up video on Docker deployment and other types of deployment. So let's get going. Okay, so I've got my R project set up. I'll just get rid of this in the environment. Okay, so first of all, we're going to create the machine learning model. Okay, so this file's already been set up and I'll take you through what we've developed step by step. So, a couple of packages that we're going to need for this, some you might not have seen. So NHSR datasets is available on CRAN and can be downloaded by going to your package installation window, clicking install, NHSR datasets is there. Additionally, I'll use a custom package in this that I've designed called Confusion Tabler, which essentially collapses down outputs of the CARET models, so the CARET confusion matrix, so you can store them in databases and spreadsheets. So we're going to highlight all these libraries. So we're bringing in NHSR datasets, dplyr, tidyr, var handle, migrator, all sample, CARET, Confusion Tabler, task scheduler, and data table. So initially this would be the script used to build your model and perhaps retrain your model every time it's needed to be retrained. So I'll take you through the first step. So here, the NHSR datasets has got a stranded data frame. So we're going to load that into the environment first of all, and we'll inspect this. Let me just get rid of my viewer window. We'll inspect this, and you can see we've got a classification tag of whether a patient's stranded or not stranded. So by stranded and not stranded, we normally refer to a patient, so an inpatient that's had a length of stay longer than 7 days. So it's a terminology, but this is going to act as our binary classifier for our machine learning model. And we're going to use a bagged tree, so a bagging algorithm, tree of trees, to vote on this and make the best prediction. So the field structure, we've got age, so the age of the patient, a flag to indicate whether they've been referred via a care home, something called whether they're medically safe for discharge, so are they in hospital but they should be transferred out. HCOP, so that's an acronym for healthcare for elderly people. Are they flagged as a healthcare for elderly person patient? Have they got mental health needs, and do they need assessments? Have they had any previous inpatient admissions in the last 12 months? An admit date, admittedly we're not going to use this field, and a frailty description. So there's 4 indicators there, or 4 factors. There's a factor with 4 levels: no index, mobility problems, full patient history, and whether they've got activity limitations. So I'm just going to get out of this for a minute, and we've run that, so now it's in our environment. The next stage of the process is to, on our frail model, if you can remember, this won't work in a machine learning context because they're categorical descriptions. So what we're going to do is we're going to create something called a dummy encoding. So a dummy encoding essentially is like a data flag. It labels it, if it belongs in that category, a 1 or a 0. And we're going to drop our reference column of no index once this is completed. So we're going to run the cats line. Now you can see the cats has coded this up. So we've now got these categorical variables encoded into a numerical representation. So you can now see that actually some patients got activity limitations, some have got patient full history and mobility problems. The final step here is we have this stranded data frame before. We've got this dummy encoded frame two separate frames, one with 9 variables, one with 3. We're going to column bind them back together to create the master data set. And then we're going to drop admit date and the original frailty description, which was a categorical variable. That'll overwrite the original stranded data. So it's gone up to now 10 variables of 699 observations. Admittedly, you'd probably want more than this if you were creating a machine learning model. 699 observations is not massive. Now what I'm going to do is use R sample. So we're going to do an initial split on the stranded data, and we're going to do a proportion, so about 75% on the training and 25% on the test. And I'm going to label these the training data and the testing data. So we're going to run those lines. As you can see now, I've got my training data and it's been sampled, and we've got all numerical data apart from our categorical variable that we're going to predict on. One last thing about this particular data set, it's got a class imbalance problem. So there's more patients in hospital that aren't stranded than are. So we need to upsample that. So I've created an upsample ratio and a calculation to do that here. So I'm going to run this. If you look at the upsample ratio, it's going to upsample it by about 34.5% in the minority class. Now we're going to use the CARET train function. So CARET's an older machine learning library for R, but I still think it offers a lot more flexibility than tidy models. So I'm going to create a tree bag, so a bagged tree, which is an ensemble approach to classification and decision trees. So this might take a little while to train. Okay, that wasn't too bad. So that's now trained, and what we're going to do now, you can see the TB model's been returned as a list. If I drop that down, it'll have the CARET list structure. Now we're going to predict a model with our test data. So we use the predict function. What we're going to pass in is the model, so it's the trained CARET model we've just used, and we're going to use our test data to validate this. This is quite a simple approach to partitioning machine learning data. I normally prefer to use a k-fold cross-validation approach to separate my training data sets into about 10 folds, and then have a final validation holdout set that I train against the kind of resampled, weighted k-means observations. So essentially for a k-fold classification, it'll split it down and make separate classifications against our predictive model. Again, keeping it simple, we're going to use the test data, and we're going to use the type equal to raw. So the raw will return the raw classification labels. Now we're going to get the probabilities as well. So I'm going to run those two lines, and I'm going to bind them together in an overall predictions data frame. And let's just analyze this. So your predictions data frame should exactly match your test data in terms of number of observations, because it's your test data that you've used against your training data set that's been trained on the model. So now 174 should directly bind back together. So what you could do with the test data is bind these predictions to it. I'm going to leave it as a separate frame for now. But as you can see, we've got our prediction, class prediction of not stranded or stranded. This, you could calculate these class predictions based on the probabilities. So 76% stranded, we know that that's probably going to be stranded if you take a rule of anything above 50% is going to be classified as stranded, and anything below is not stranded, something like that. And you can see they kind of directly align with the predictions we've made. Okay. Next bit, what we're going to do is we're going to use the CARET confusion matrices, and this is also useful for working with tidy models as well. We're going to use that, and we're going to essentially say on the test data, I'm going to use the predicted column, so what we've predicted in the predictions against our test data, and we're just going to look at the stranded class label. So this is a column row logical operation, saying if it's in the names test data as in the stranded class, then bring out that particular column. So I'm going to run that as a confusion matrix. And then what I'm going to do is use the package confusion tabler to create a binary class of that confusion matrix. This is something that I created. And then we can fast write that out using data table, very quick, to a CSV. This could also be stored in a database table if you wanted to assess what your data set looks like and what your model fit looks like day by day or whenever you retrain the model. So if we go to open that, you'll see that inside this folder, production folder, I'll just bring this on here. We've got a confusion matrix. And let me just zoom into that. What this does is essentially takes the flat confusion matrix and puts it on a row by row basis so it can be loaded into a database. And it gives a timestamp of when it's been created. But we can see actually our model's really accurate. And what I'm looking for is the sensitivity. So the sensitivity is absolutely perfect. So you couldn't get much better with this model. Okay, I'm just going to come out of that. So yeah, we've got this confusion matrix. There's a couple more options that you could use in the confusion tabler. It's just confusion tabler. There's details about how to install it in the source files. Tabler. You have to use the remotes package. So if you want to visualize that confusion matrix, we can use the binary visualizer for binary classification tasks. So essentially that just creates a nice graphic of the confusion matrix. If you had a multiple classification task, you'd use the multi-class confusion matrix, but we've only got a binary dependent variable of it as in stranded and not stranded. And if you wanted to look at the variable importance for the model, so TB model, the confusion tabler has got a function for that as well. Okay. So our global variable importance, age is having the biggest effect, and that's the var imper. So variable importance having the biggest effect. And again, you can see this in terms of metrics. It creates a list. So if I save this as a list, conf tabler, you can see that it's a list item. It's got a stored plot and it's got a stored model, which is a tibble that you can utilize. I'm just going off track a little bit, but I just wanted to show you that. Okay. So the next thing to do, you can either serialize it. This works really well with models such as Python and things like that. So you can do a raw serialization. But what I'm going to do here is save an RDS file. So it's a single file, and this will be our bagged model. We're going to save this in our working directory here. So make sure this is your working directory. I'm going to save that. Okay, so now that's saved. What you'd then do is, if you were creating a machine learning pipeline, you'd hook this model up to save to retrain every week based on your incoming data, and it'd just output it to a file store, or you could hook it into SQL Server, or put it on a cloud solution, whatever floats your boat, or even a Dockerized container. Okay, so that's the training part, that's machine learning part of the task done. The next phase then, we'll just clear our window, Control and L. The next phase is to create the stranded patient API. Okay, so this uses a package called Plumber. You'll need to install Plumber. And if the model depends on any packages, you would need to make sure that they're exposed when you load this script file. Okay, so Plumber is essentially a way to create an API. So you can pass data into your model through something called a Swagger UI, which is something that's common. If you have RStudio Cloud, you can deploy it straight with RStudio Connect, Otherwise, you have to think about other deployment solutions once you've built this, things like Docker files or open lakes, that kind of thing. But for now, we're just going to show you, I'm going to show you how you can do it. So we've got library Plumber, library CARET, library JSON Lite, IPRED, which belongs to the specific prediction E1071 for tree rules, and YAML, because we're going to use a YAML file, and I'll take you through that shortly. So the model that we created, we're going to read in the model using read_r, read_rds. We're going to link to the tb_model.rds here. So I'm going to clear this file here, and I'm going to run this as a separate set of scripts. Again, because this is an API, I'm going to do this with Control and Enter for each line to make sure it all works. Okay, they're all fine. My model, you can see my model's just been read in. It's the same model that I trained earlier. Okay, I'm just going to have a look at model info, print out some details for you. So, what we're going to do now is a get and a post request. So the get's not so important because it pulls back from a website the connection status, but actually from the other end. So if you've ever submitted a form or been on a shopping cart or essentially used an online calculator, that uses post requests. So post requests are sending requests from the web browser to your application. So what it'll end up doing is we'll have a JSON API, which I'll show you shortly. It will do a post request, look at your model will send the results back to that the thing that's requested it, and then it will be displayed in the web browser. So important things then. So this part is the get request, and this is just going to test the connection status. You can pass in whatever you want into this list. Connection to stranded patient API successful, and the time that it happened, and you can even put, let's say, username. Let's create sys get inv. I'm going to use the username option. Okay, this bit's the most important bit. So here, this is where you're going to expose the probabilities to the API. So the request and the result you need to highlight. So when it's requested, what will be sent over in the JSON will be a body of text, and it's that we need to look for in the body. That'll become apparent in a minute. We're going to use a data frame. We're going to wrap it in the predict method that we saw earlier. So we did a prediction on the test data. It's exactly the same process. We're going to set the new data equal to the JSON that's coming back from our API. And we're going to use the predict function type equals probability. So return the probabilities of belonging to those specific classes. And then here, these things here specify what type of connection you're going to have. So they're specific Plumber hots codes. So if I change one of these, look here, it'll come up with some IntelliSense at get. Yeah. It's specific notation, tagging a bit like our markdown. So we're going to call this one connection status, and that's important. That's a get request. And we're going to call this one predict, which is our post request. So the post request will be sending stuff from our API. And the final thing, we're going to create a function. So this set API specification, this will set what Swagger looks like. And then what I'm going to do initially is I'm going to show you how the API works. So we're going to run this API, and it's loaded in my other window. And as you can see, we've got our stranded patient prediction tool. So this has got some functions like contact the developer, that's my name. The test server that it's running on. So if you deploy this, this would actually be the live server that the API belongs to. Because I'm using this for test purposes, then it'll only be available to my local machine, but it's just to try and show you the concept. So the get request is going to give us all these default parameters, no parameters. So we're going to say try this out. And here I'm going to hit execute. So you can see that it's done a curl request. My request URL is connection status, what we specified earlier. And you can see we've added that other parameter additionally, status, Connection to stranded patient API has been successful this time, and the username is Gary H. And you can see the response headers there. Okay. The real power becomes in the post requests. So here, this is how I've set it out, and this is essentially all the parameters in my model. If I go back to my R window a second, and I went to, I've saved these in a file. But yeah, essentially all the parameters for the model, so the trained model, it'll be the field names that you've passed through your model. So that's important that they match. So going back to our API, now we're going to do some real fun stuff. So I'm going to try our new API out. So age, so you can tweak these, say 49. And what this is going to do is fire off to our prediction model. And if you can see, it's sent a response back when I press execute. So age equals 49. What's the probability of that patient being stranded or not stranded? In this instance, it's not stranded. Okay, because we've also specified that it's going to receive it as a data frame, we can send multiple requests. So in Json tagging, which is the way that browsers pass between, we're going to just put some parameters, some list parameters here, and then I'm going to copy this bit again here. Just do that after the comma. We're going to set this to 89, sorry. I'm going to tweak a couple of these to 1, and then I'm going to put another one after this and do it again. So we've got essentially 3 predictions we're passing through. So I'm going to execute that. And you can see that actually it's give us 3 JSON tags, which we could interrogate back into R if we wanted to and read the JSON using JSON Lite. You can see it's got the prediction probabilities that have been returned now. And this is essentially how all APIs work. You pass it through something, and this is how you could deploy your machine learning model out into the live environment. Okay, so how did I make it look like this, you ask? Okay, so if I go to my open API, and this will be contained in the GitHub alongside this, what we're going to specify is the open API number, a description of the API description, the version of R, the title, and then this bit's important. So I'll pass for connection status, the summary checks our API service is running. Our predict will be all the values that we're going to pass through. So responses, parameters, request body, the type of object, the age, whether it's a care home flag, whether it's medically safe, and the data types as well. And this in a kind of nice YAML format. You could amend this for your own specific projects, but it allows you to go through and set particular parameter values. Again, I'll share this with a GitHub that supports the tool. Okay, so now what you'd want to do going forward, really, so bringing up the Plumber documentation. So that's the machine learning, training the model, saving the model, creating a Plumber API, which creates a Swagger user interface that you can pass and interact between. You'd want to understand how you can deploy this. So this is the Plumber documentation for hosting on Docker. Says you can use, if you've got an RStudio Connect account, it's a lot easier with that. You can buy a DigitalOcean Linux virtual machine for a couple of pounds a month, which what you pay while it's online. But actually there's the potential just to deploy it as Docker files. So this shows you how to create a Docker file, and you can create custom Docker files. What you'd need to install is the run, and you need to make sure that everything that your package needs is set up in that local environment. And again, there's some good. I'll probably do this in the next webinar. I'll show you how to deploy this tool into Docker. But for now, that essentially completes this part of the process. I hope you found that interesting, and I look forward to doing another tutorial for you on Hutsons-Hacks. Stay tuned.